Right, so we have got that question. Right, I just want to remind you that I already started doing interpretation of the cubic graph. I combined the two, the sketching and the interpretation. Okay, so we are given that sketch. Now, this sketch here is for the what? First derivative. Okay, you're paying attention in last week's lesson. You were supposed to be able to do this question without any problems. Okay, but if you don't know your basics, this question will give you a hard time to do it. Okay, you might not even know where to start. But so you are given a graph here of a cubic graph, sorry, of the derivative of the cubic graph. Now, if you look at this question, there are some key things that you need to be aware of. Right? The x-intercept here, the x-intercept 0.8 is an x-intercept of the first derivative, which is quadratic. It's also the x-intercept of the original cubic graph. Okay, so you're supposed to be aware of that. Now let's start with the first question. Now the first question says, show that the numeric value of b is equal to -9. Clearly show all your calculations. Okay? But before I show you how I did the question, those of you who did the question, how did you approach it? Yes, yes, what?
You just found you sub in a into the p prime x, then you solve for b.
Okay, so it means you have to find the derivative first. Okay? You need to find p prime of x. Then you substitute the coordinates of a. Okay, so I'm gonna do that. Okay. Can someone tell me the equation? It's p is 8.4.1. P of x is equal to what?
3x squared
3x squared
plus 2bx.
No, we want the cubic.
Oh, sorry. X cubed
It's x cubed
plus bx squared
plus b.
bx squared
P.
b
x squared
plus 24x
plus 24x plus c. I see both are wearing a mask. The voice is going to be a bit exaggerated. Okay, so p prime of x is going to be equal to 3x squared plus 2bx plus 24. Okay, all right? Now, why are we using the first derivative to find b? What is the concept? Yes, question.
we removed the unknown value of c.
Okay, one want to remove the unknown value of c. What's the other reason? I told you the reason earlier in the lesson. Okay, let's go back to the graph. If a point like this, forget about that. Right? If a point like this A is an x-intercept, what does that tell you about the turning point of the cubic graph? It means one of the two turning points is on the what? X-axis. Which means the derivative, the first derivative is equal to what? To 0. That's why we have to use the first derivative to find the value of b. It's because one of the two turning points of the original cubic function or graph, okay, has got an x-intercept, okay, which is on the x-axis. Or rather, it has got a turning point which is on the x-axis. Okay, which means the first derivative is equal to 0. on the x-axis. All right? That's why we are using that. So here, our y is 0. Okay, so you get your 4b being equal to minus 36 and then b equal to minus 9. Right. The question is saying show. Don't try to substitute this b equal to minus 9 into an equation and then you work backward. No. Show us how you get the minus 9. Where did it come from? Okay. So use the fact that the cubic graph is a turning point on the x-axis. Therefore, the first derivative is equal to 0. So that's how we actually approach the question. And one of the reasons is to eliminate that c, because the moment we have got two unknowns, means we need to formulate two equations. And that can complicate things. All right, so that's how we got the minus 9. In the next question, calculate the coordinates of C. Okay, you need to calculate the coordinates of C. That's the point there. Right? It's an x-intercept of the what? Quadratic. Okay, we know that here, x is 2, y is 0. But we don't know what the value of x there is. But the good thing is, we have already found b. Okay. Well, I don't know how you would approach it, but in my case, I would approach it. I've got two ways of approaching the question. But I want to hear how you approach it. Quickly, please. Quickly. How did you do it? Yes, Michael.
Since you already know the value of p, that means we have the full equation for fp of prime x, which is the first derivative. Since you have the full equation, and then you just find the roots of that equation. One of those roots would be equal to a, and the other one would be the coordinates of c.
Yes, thank you. So if you want to find the coordinate of c, you can use the first derivative. Okay? First derivative is quadratic. And you just find your first derivative, you set it to 0, you solve for what? For x. You get two x values. One of them is going to be x equal to 2, and the other one is going to be whatever is there. Alright? Okay? And remember, to get the only way that you can get that is by making sure that you substitute the value of b into the cubic function, then you find your first derivative. Okay, please don't make the mistake. You have to substitute the b equal to minus 9, find your first derivative, then equate it to what? To 0. Is there any other way besides that? Is there any other way? Because that's not the only way. Is there any other way? Because you can't tell me that all of you would approach it the way that you tend to say. It's not possible. Any other way? And I'll share with you the other way. So we have that. Let's move on. That will be 8.4.2. So our p prime of x will be equal to 3x squared. And what's the next step? Minus 18x plus 24. Then we set that to 0. Why are you talking? Why are you talking? straightforward. Find the first derivative, equate it to 0, solve for x. Everything that I've done here, the calculus is here. That's where the calculus is. This from here is no longer calculus. This is no longer calculus. It's knowledge of previous grades. Grade 9, 10, 11. Okay, the calculus is there. Okay. Right. Don't have any question, then I'm going to show you how I would approach it. Right. Let's say because you see, when you're in an examination, the way you can think can differ. In actual fact, I expect people to approach this question in more than one way. You can find your second derivative. Okay? Find your second derivative, determine the value of x at the turning point of the quadratic. Okay? Or you can just use any other technique you know of finding the x value at the turning point. Okay? And so far, you now have about, I think, 3 or 4 ways to find the x value at the turning point. Okay? So, I'm just going to show you one way. Okay? I'm just going to show you one way. So, maybe I can call this one method 2 for that problem. The other one, you can call it method 1. Alright, so our p prime of x is 3x squared minus 18x plus 24. Okay? You can find the x value at the turning point. Because, you see, someone might not realize that, okay, you can equate it to 0. But at least you must have another way of doing it. So let's find x value at the turning point. So that x value is equal to minus b over 2a.
Yes.
Okay? Remember, you can also use calculus. At the turning point, the first derivative is equal to what? To 0. Okay? So in that case, means your second derivative is going to be equal to 0. So you get minus 18 over 2 times 3. So you get x equal to 18 over 6. And that's it. Okay? Pay attention. So, at the turning point of that first derivative of the quadratic function, the value of x is a 3. Okay? Let's go back to the... So, x is 3 here. X is equal to what? To 3. There. I hope you know that this x equal to 3 is also the axis of what? Of symmetry. Okay? Which means if I add the value of x here and the value of x there, I can use the midpoint. Add those two, divide by what? By 2. I can get this 3. Okay? So let me do it here. I hope you are paying attention. So my 3, this x equal to 3, is a result of adding x1 plus x2 and dividing by 2. But this x1 is a 2. So you can get 6 here equal to 2 plus x2. And your x2 will be a 4. Okay? So you can also approach it that way. But the first method is the easiest stuff. But if you don't realize, you can approach it that way. Okay? Then you can end up saying, therefore, x is 4, y is 0. The way, whichever method you can use to find the x value at the turning point. Remember, there are more than 3 methods. I would say maybe there are at least 3 methods of finding this x value. You can just go ahead, just like that. Okay, remember you are in grade 12 now, so you must have different ways of doing this problem. Right, any question? Right, if you don't have a question, then let's carry on. Right, 8.4.3, for which values of x will p of x increase? For which values of x will p of x increase? For which values of x will p of x increase? How did you do that? Without sketching the graph. You're supposed to determine for what values of x is the cubic graph an increasing function.
So we are going without sketching.
Yes. How did you approach the minute?
So I use the X value for the turning point.
So be very specific. The x value of the turning point of what? Of the quadratic.
That graph. So I say
Did you use the x-intercept or you use the turning point of the quadratic?
the turning point of the quadratic graph. That graph.
But how did you use the first derivative? That's my question. Did you do the first? Huh? Okay,
We know that.
okay, can you be quiet?
We know that the x values of the x-intercepts of the first derivative are the x values of the turning points of the cubic graph.
Yeah.
If you take those x values and you substitute them into the second derivative, you can determine whether the answer is negative or positive, and therefore determine whether that specific turning point on the original cubic graph is a maximum turning point or a minimum turning point, and then say which x values you want.
Okay. Listen. Okay, listen. I understand what you're saying. Alright, if you look at this equation for P of x, the coefficient of x cubed is positive. What does that tell you about the original cubic graph? It starts with a maximum or a minimum turning point. Maximum. So it means the shape, pay attention. The shape is gonna look like this. That's the shape of what? P of x. Okay? That's the shape of what? P of x. Okay? What that means is here, x is gonna be 2. Okay? X is gonna be 2. And here, x is gonna be what? 4. Are you following that?
Yes.
Yeah, so if you don't know the shape of the cubic graph, you're gonna have some challenges. So knowing the shape of your cubic graph first is very, very important. Okay, so it's gonna be a decreasing function between x equal to 2 and x equal to what? To 4. So your answer there is gonna be, here it says will P of x be an increasing function. So it's gonna be when x is less than 2, okay, or when x is greater than what? 4. P of x is an increasing function when x is less than 2 and when x is greater than 4. How many of you got that? Thank you. Let's move on to 8.4.4. Now, calculate the value of x for which the graph of P is concave up. How did you do that? Do you use the second derivative? Yes. Today I'm going to show you a second method, which is probably easier. Using, okay, already we know that, remember, the x value at the turning point of the first derivative is the x value at the point of inflection. Remember that?
Yes.
Hey, stop looking down, you look here. The x value, listen, the x value at the turning point of the first derivative, which is quadratic, is the same x value at the point of inflection. Which means this x value here that we got earlier, x equal to 3. Remember, if it's concave up, means we have a what? A minimum turning point. concave up. Means we have a minimum turning point. So we are talking about somewhere from here going that way. That's when it's what? Concave up. So your solution there is going to be x is greater than what? 3. If you think you can get confused there, then go by the inequality. Okay? Find your second derivative, substitute. Because remember, if it's concave up, you can do it this way. Concave up. Second derivative is greater than what? 0. Okay? What's your second derivative of p of x? 6x minus what? 18. Like that. So we get 6x greater than 18. Therefore, x is greater than what? 3. Okay. Another way, let's say you were not given the quadratic function, but you know the x value at the maximum turning point and at the minimum. I hope you are aware. I'm not sure whether I told you this, but you can find the x value at the point of inflection by adding the x values at the turning point, then dividing by 2. How many of you are aware of that? The value of x, listen, the value of x at the point of inflection can also be determined by adding the x values, or rather by finding the average of x values at the turning point of the cubic graph. So if you add 2 plus 4, you divide by 2, you get what? 3. That's the value of x at the point of inflection. Okay? And then you can go to your graph, use common sense to get your answer. Okay? Any question there? Now, these are common questions. Increasing, decreasing functions. Concavity. They are common questions. For this paper, this one has 2 marks. But sometimes you can have 3. Right, we'll continue tomorrow on this. And, on Wednesday.